Please write this question. This is a very similar question to what we did yesterday. Yesterday we did one question on Rawls law. So this question is very similar to that. And I should also say it is more easy. It is easier.
Okay.
Let me know if you are facing any difficulty. So let me outline how to calculate. So you may stop writing right now and listen. So we have been given the vapor pressure of pure benzene, that is 0.256 bar. That means we have been given the P naught of C6H6. Okay. P naught of benzene, that is C6H6. Let me write benzene like Ben. Okay. This is equal to 0.256 bar. Then the vapor pressure of pure toluene, it is 0.0925 bar. So P naught of toluene, it is equal to 0.0925 bar. Okay. If the mole fraction of benzene in solution is what? 0.40. It is equal to how much? 0.40. So they have also given you chi of benzene, which is equal to 0.40. So chi of toluene will be equal to 0.60. I hope all of you know. And then you can calculate what is the total vapor pressure of the solution. So P total will be equal to P naught A chi A plus P naught B chi A. So you can keep, you can choose A as benzene or toluene as you want, and you have all of these 4 terms. Is that right? Yes or no? Please tell me. Dania and Hanifa.
Yes.
Okay.
Yes,
So you can
sir.
easily calculate this. You can easily calculate this. And after that, once you have calculated, so this P naught A chi A, it will give you, for example, let us say the pressure due to benzene, and the partial pressure due to benzene, and this will give you the partial pressure due to toluene, let us say. And when you need to calculate the composition means what? You have to calculate the mole fraction of each component in vapor, of the vapors. When you have vapor phase, you have to calculate the composition of vapor phase in terms of mole fraction. So in order to calculate what you would write, you will write Y of benzene will be equal to the partial pressure of benzene divided by the P total that you have calculated from here. This is the P total that you need, and then the P of benzene. So please calculate this. Let me know when you're done. And send the answers in chat also. Send the answers in chat.
Sir, the mole fraction for benzene is 0.05.
Mole fraction for benzene in the vapor phase, right?
Yes.
Can you send the answer in chat? It will be better. Acha, by the way, did you calculate the P total first? Tell me.
Sir.
Huh? Anipa?
Yes, sir.
Okay. You send me the answers, है ना? For P total. P total बताइए उसके बाद.
Stop acting like you're depressed. No, you just did my. But
Mhm. Waiting for answers, Dania and Hanifa. Okay, fine. That is for Y of benzene. Okay. Waiting for Y of toluene. So you can just minus 1 minus the mole fraction of benzene will be equal to that for toluene. So what about Dania? Dania, आपको आया आंसर P total?
Yes, sir, just 1 second.
Okay. Assalamualaikum Zaid.
Walaikum salam.
What happened? Why are you so late?
Sir, I missed time.
Okay, you lost the track of time.
Yes.
Put up some alarm or some kind, है ना?
Yes.
You had school today?
Yeah, online class was there.
Online, so it is going
Yeah.
hybrid.
Both. Like on Sunday, physics teacher takes the class online. So because portion is going behind the delaying.
Sorry, what did you say?
The portion is like very delaying. So in physics, we are having online classes on Sunday and Saturday.
Okay. So only physics, nothing else.
Yeah, only physics.
Okay. So you have like 3-day weekend, huh? Friday, Saturday, Sunday.
Yes.
Oh, that's nice.
Actually,
So you
they
have to-
increased the normal days. They increased 1 hour, or I think 1.5 hour of the school. Yeah.
Okay. So usually when the school when does the school end?
It for like normal days it ends on 3:30, and
Okay.
I reach home at about 5:30.
3:30 and 5:30. Yes, Dania, waiting for your answer. What happened? Dania, you have to send it to Salim.
Okay, sir.
Dania, can you please turn the mic on? इतना time तो नहीं लगना चाहिए. Dania, can you please turn the mic on?
Yes, sir.
हाँ बताइए. P naught A कितना है?
0.256.
Okay. 0.256 into. What is the mole fraction of A? Tell me what is the mole fraction of A? इतना टाइम क्यों लग रहा है तानिया? Keep your mic on ना.
Yes, sir.
हाँ
0.40.
इतना टाइम क्यों लग रहा है दानिया? Why you are taking so much of time? Tell me P naught B, जल्दी बोलिए.
0.0925 into
0.0 हाँ into, very good, into
mm, mole fraction of B is
what is the mole fraction of B? A को आपने A को क्या लिया आपने? A को
0.60.
आप इतना ये क्यों आपको टाइम लग रहा है? इतना टाइम लगाने के बाद भी आप इतना धीरे धीरे आंसर कर रही हैं, ऐसे नहीं होना चाहिए ना. A को आपने बेंजीन लिया, B को टॉलुइन लिया है, यस और नो प्लीज टेल मी दानिया.
Yes, sir.
तो फिर इतना टाइम क्यों लग रहा है आपको? ये तो सारी इन्फॉर्मेशन हमने यहाँ पे लिखा हुआ है सब कुछ. बेंजीन का मोल फ्रैक्शन, टॉलुइन का मोल फ्रैक्शन 0.60. ठीक है ना. 256 इंटू 0.4, बताइए कितना आंसर आया था इसका?
0.10.
1024 आएगा. ठीक है. ठीक है. मल्टीप्लीकेशन में ये मतलब गड़बड़ी मत कीजिए आप लोग. ठीक है ना. द थिंग दैट आई हैव सेड ना, एटलीस्ट 2 नॉन जीरो डिजिट्स आफ्टर द डेसिमल पॉइंट, दैट इज ओनली फॉर डिवीजन, बिकॉज डिवीजन में आपको एंड कहाँ तक होगा पता नहीं है. इन मल्टीप्लीकेशन यू ऑलवेज नो वेयर विल बी द एंड. नाउ टेल मी फॉर दिस वन 0.0925 into 6 into
0.55.
0.55.
0.555.
नहीं, 0.0555 होगा. ठीक है. अगर आप इन
Okay.
दोनों को मल्टीप्लाई कीजिएगा, इफ यू चेक इट है ना, यू चेक इट, सो टू मल्टीप्लाई दीज टू थिंग्स यू विल गेट दैट 925 into 6 आपको कितना मिलेगा? दिस विल बी 555. ओके.
Yes, sir. Okay, sir.
6 5 नहीं, 555 0 आएगा. हाँ इतना आएगा. ठीक है. एंड हाउ मेनी यू हैव टू पुट इट हाउ मच बैक? सो 1 2 3 4 and 5. So 1 2 3 4 and 5, 0.0555 0. इन दोनों को मिला के कितना आ जाएगा पी टोटल बताइए?
0.0679.
0.
067.
इन दोनों को ऐड करने से कैसी बातें कर रही हैं आप?
Sorry, sir. 0.1574.
158 ले लें, ठीक है। और आपने क्या आंसर किया है? What is your answer, Dania, that you have sent me in the chat? Tell me.
Yes, sir, I did that wrong.
वाह,
I messed up the numbers.
साफ साफ आपने यहां से स्टार्ट किया क्या सीधा? हाँ, ये लिखा था आपने?
Yes, sir.
ये लिखा था आपने, फिर भी आपने क्यों मिस्टेक किया भाई? नंबर्स कैसे मिसअप कर दिए यहाँ पे? कॉपी करने में मिसअप किया आपने? दानिया,
Yes, sir.
in copying or stuff. Okay, fine. So this will be 0.058. Next is the mole fraction of benzene. That means in vapor phase, Y of benzene will be equal to the pressure of benzene divided by P total. Pressure of benzene is equal to how much? देखिए ये है आपका pressure of benzene 0.1024 divided by 0.158. ठीक है, ये भी बार में, ये भी बार में है. So this will come as to be कितना आया था? 0.648, I think it is 648, or you can approximate this as to 0.65 also. And that is why the mole fraction of toluene will be equal to 1 minus 0.65, which will be equal to how much? 0.35. Okay, so these are the two answers. कैलकुलेट कीजिएगा इसको घर में, अभी छापने की कोई जरूरत नहीं है आप लोगों को, ठीक है। नाउ राइट द टॉपिक रॉल्स लॉ एज स्पेशल केस फॉर हेनरीज लॉ. Special case of Henry's law. Okay. Now, in this topic, we'll understand what is the similarity between Rod's law and Henry's law, and how they are different. So, if you remember Rod's law, generally लोगों को क्या लगता है? P total it is equal to P naught A chi A plus P naught B chi B. ये Rod's law है ना? But this is not the Rod's law. If you look at the statement, Rod's law states that partial pressure of partial vapor pressure, and partial vapor pressure of any liquid or the component of solution PA, it is directly proportional to chi, and that means it is saying PA is equal to P naught A chi A. This is the Rod's law, है ना? इसके बाद जो P naught P total वाला, that is the application of Rod's law. What is Henry's law? Henry's law says that the partial pressure of any solution will be equal to the Henry's constant times its mole fraction. Its mole fraction. Now, in this case, you can see that we get the pressure. Here also we are getting the pressure, and we are using the term that is mole fraction. And as the mole fraction increases, the pressure due to that component is also increasing. And also there is a constant. This P naught A is also a constant. This KH is also a constant. And both of these constants depend on, they depend on what? They only depend on the temperature. And if temperature is higher, KH will be higher, if then P naught A will also be higher. The vapor pressure will also be higher. Also, one more thing is that, please listen very carefully. We all know that if KH is high, solubility is low, है ना? ये Henry's law में हम लोगों ने पढ़ा था. KH is high, then solubility is low. Look at this P naught A. P naught A means the vapor pressure. That means if P naught A is high, there are more vapors.
Yes, sir.
Right? If more vapors are there, that means the A is escaping solution. Correct? Yes or no? And if
Yes.
A is escaping solution, that also means I can say that solubility is low, है ना? Then it means also I can say its solubility is low. Yes or no? Right?
Yes.
So it is very similar. Both Rod's law and Henry's law, these are similar. What is the special case here? What is the special case? Now, Henry's law is there for gases, and if you compress the gas, you will come to Rod's law. If when you compress the gas at a very high, that means if you compress the gas, it will become Rod's law. The other way you can state that Rod's law is there, and if you this P naught A, it becomes very, very, very high. P naught A becomes very, very, very high at 25 degrees Celsius. You are getting only vapors, है ना? At 25 degrees Celsius, if you are getting only vapors, that means at normal temperature, your A component is gas. If your A component is gas, that means you have to apply the Henry's law, and the Rod's law will no longer be applicable. Okay, so you will write with me here. Please write this with me. Rod's law becomes Rawls law becomes a special case of Henry's law in which KH becomes equal to the vapor pressure of pure liquid. Okay, or rather I should say, wait a second, pure component लिख देते ज़्यादा बेहतर होगा. Pure component. All of you done writing yes or no? Please tell me. Okay, just waiting for Dania. Okay, fine. Now, the next topic is ideal solution and non-ideal solution. Ideal solution and non-ideal solution. Now, before defining ideal solution and non-ideal solution, let me explain what all of these things are, and then we will start writing everything. Okay, so please pay attention. Okay, leave your pen aside. Don't write anything. Yeah, this is very humble request. Please leave your pen aside. रख ही दीजिए बिल्कुल, लिखना ही नहीं. Okay, so the topic is ideal solution and non-ideal solution. Okay, now if you remember the application of Rod's law, it says that the P total will be equal to P naught A chi A plus P naught B chi B. Okay, now I am shading it in two parts. Let us say that this is, what is this color? Pink. Pink बोल सकते हैं इसको? हाँ?
Yes.
Yes or no? Tell me. This is pink. Okay. Then we have this blue. So tell me which of this highlighted color, which part? LHS या RHS में तो ये कौन सा part है जिसको measure किया जाता है, कौन सा part है जिसको calculate किया जाता है? Which is measured and which is calculated?
Left hand side is measured and right hand side is calculated.
सबको पता है ना ये चीज? Yes or no? Hanifa, Tania,
Yes, sir.
Hanifa and Tania, do you remember? है ना? P total हम लोग measure कर सकते हैं ना? What we can do, we can measure the P total. If I have a gas, some gas like this, there is some vapor pressure. I will put a manometer or a barometer and I will measure the P total. But this P naught A, chi A, mole fraction यहाँ से measure नहीं किया जा सकता. So these things should be calculated only. Okay, so now what we see that we have this one which is measured, and this is the portion that should be calculated. So the portion that should be calculated. Okay, calculated. अब देखिए, what did you take? You took a container. Please don't write anything. Listen to me. Now you took a container in which you added some liquid A. Okay, and then there is some another okay, and then here we have vapors. Okay, now you know the of this aqueous solution, you know what is P naught A, you have the value, you know also what is chi A, okay, and you also know what is P naught B, and you also know what is chi B. Why? Because you are the one who has prepared this solution. Okay, you are the one who has prepared the solution, so you know all the mole fraction and the vapor pressure of the pure components also. Then what you can do, you can plug in the values in this equation P naught A chi A plus P naught B chi B, and then you can calculate, and that will be your pressure that is calculated. Yes or no? And what else? The other thing that you can do is, now all of these things that you have done this in your notebook, and आपने measure नहीं किया, you have calculated this. Now you can also use a manometer or a barometer, and then you can measure P total. And you'll see that this is P total. This P is experimental, and we have done experimental, and we have put up a tool, an instrument, and we have measured it. Now you have two terms, P experimental and P calculated. Okay, P experimental and P calculated. Now there can be three cases. There can be three cases when there can be a case in which P experimental is equal to the P calculated. Another case can be P experimental is what, and two cases लेके चलते पहले, not equal to P calculated, है ना? अब not equal में आपके पास दो केस बन जाएंगे. One case will be if P experimental is greater than P calculated and P experimental is less than P calculated. Okay, so basically we have initially two major divisions. If P experimental is equal to P calculated, then it is going to be ideal solution, and if it is not equal, that means it is non-ideal solution. Okay, so you got the basic gist of the concept, yes or no? Please tell me.
Yes, sir.
What about others, Hanifa and Dania?
Sure.
Yeah, any questions till here? Yes or no? Please tell me.
No, sir.
Yes.
No question, right? Now let us look at the reasons, and I'm asking you, let us look at the reason. Now it should be equal, right? इतना आपको लगता होगा that they should be equal. The experimental pressure and the calculated pressure should be equal. Yes or no?
Yes, sir.
है ना? They should be equal. इसके लिए आपको explanation की जरूरत नहीं पड़ेगी. Let us see why they are not equal. Okay, why they are not equal. Now again, I will ask you to not write anything. Just listen to me. Not write anything and just listen to me. Okay. Initially, before mixing, we have the solvent A. Now, the solvent A will have intermolecular force of attraction, let us say AA, and there will be another component that is B. They will be having intermolecular force of attraction, that is BB. And when we mix them, as soon as we mix them and they solve and they dissolve into each other, we mix them. So I will get two different intermolecular interaction, that is AB interaction, and I will also get one more AB interaction. Okay, all of you understand what is happening here? Yes or no? Please tell me.
Yes, sir.
Okay, fine. Now, if we have here attraction, okay, attraction, here is also attraction, and here is also attraction. Here also we have attraction. Okay. Now, if the individual attraction of the components, if the individual attraction of the component is more, if the individual attraction of the component is more, that means the attraction before mixing is more than the attraction after mixing. Okay, this is before. Let us say that is this is before, and this is after. Okay, so what I'm saying, attraction before is what? It is greater than attraction after. And I think this is completely possible because here you are having AA and here you are having BB, but after the mixing you are having two different type, you are having different type of interaction, that is of AB. So all of you can understand, right? Attraction before can be greater than attraction after. Yes or no? Please tell me.
Yes, sir.
Dania and Hanifa.
Yes, sir.
Okay.
Yes, sir.
What will be the consequence? What will be the consequence? Attraction before is greater than attraction after. That means I can say attraction after is lower. If attraction is lower, then the molecules will be escaping easily. Yes or no?
Yes, sir.
They will escape easily. And if they are escaping easily, there will be more vapors. If there are more vapors, that means there will be more vapor pressure also. Correct? Yes or no?
Yes, correct.
Now, in this case, you can also see if there is more vapor pressure, that means the experimental will be higher than calculated. Why? If you look at the experimental is only revolving around solution. आपने जब तक solution बनाया नहीं है तब तक आप experimental को measure नहीं कर सकते. If you have not made a solution, that means you cannot measure the experimental. But if you look at the calculated thing, in this they are taking both the component individually. They're treating both the component individually. Even before making a solution, you can calculate what is the P total if you're using the calculated method, है ना? Because P naught है आपको data में मिल जाएगा. Let us suppose you will say I will have 0.6 moles, 0.6. The mole fraction of A that I want to take is 0.6. The mole fraction of B that I want to take is 0.4, and then you will easily calculate. That means if you want to calculate something, you don't need the experimental. You don't need any experiment. You can just imagine something. इतना मोल फ्रैक्शन और इतना मोल फ्रैक्शन हम लोग कंबाइन करके देखते हैं कितना पी टोटल आता है. बट इन ऑर्डर टू मेजर द पी टोटल यू हैव टू एक्चुअली मेक द सॉल्यूशन, है ना? सो आई कैन से दैट पी कैलकुलेटेड refers to the measurement that is made before mixing, and the P measured, it can be the vapor, it can be only the vapor pressure that is measured afterwards. So this will be for after mixing. So P measured, P total that is measured, it is after mixing, and the calculated is, you can say it is before, and that is why the experimental will be greater than calculated. Do you understand this point? Yes or no? Please tell me.
Yes, sir.
So where we started with attraction before and attraction after. So if attraction after is lower, the gases will escape easily. There will be more vapor. There will be more vapor pressure. And if there is more vapor pressure, and we are measuring after the mixing, that means we are measuring the P total by using a manometer or barometer, and we are getting the experimental value greater than the calculated value. Is that clear, everyone? Yes or no? Please tell me. Hanifa, Dania. Yes, Hanifa and Dania. Yes, okay, fine. Now similarly, if the attraction before is lower than attraction after, that means what I can say? I can say that if the attraction is greater afterwards, then the attraction is more or higher, and that means they will not escape easily, I will say. They will not escape easily, and that is why there will be less vapor pressure. Sorry, there will be less vapors, leading to low vapor pressure. And if there is low vapor pressure, that means this is after mixing, and that is why experimental will be lower than the calculated. So I hope I have explained all of these three things, है ना? जब P experimental आपका equal होगा, that is तो जब आप क्या होंगे, when your attraction before and attraction after are equal. Attraction before is equal to attraction after. ठीक है? Then you will get what? Then sorry, non equal to लिख दिया हमने, my bad. Is equal to attraction after. That means P total, that is experimental, will be equal to P calculated. ठीक है? P experimental, that is total, and that is experimental, will be equal to P calculated. So all of the three cases is clear. Yes or no? Please tell me. Yes or no?
Yes.
Yes. What about Hanifa and Dania?
Yes, sir.
Got these points, ना?
Yes,
ठीक है,
sir.
चलिए. अरे yes sir, आप लोग को इतना लो क्यों है? अभी last time किसने बोला yes sir? हनीफा, was that you or Dania? हनीफा और दानिया,
Yes, sir.
क्यों, क्या हो गया? Are you fine? तबीयत ठीक है आपकी?
Yes, sir.
No, you're not feeling well.
No, I'm fine, sir.
You're fine. So why your voice is so low? खाया पिया नहीं है आपने? खाया
Yes,
पिया
sir.
नहीं? Why is your voice so low?
I'm just tired.
You're just tired.
Yes, sir.
Stand up. You're sitting down somewhere.
Yes, sir.
Stand up, walk around थोड़ा, ठीक है ना? ऐसे और एकदम बिल्कुल पलंग में जाके बैठ के मत पढ़िए, या तो टेबल कुर्सी में पढ़िए. अदरवाइज यू कैन स्टैंड अप फॉर अ व्हाइल. ठीक है? ड्रिंक सम वाटर. ओके? Say yes sir loudly. Say yes sir loudly.
Yes, sir.
Thank you very much. Now moving on. Ideal and non-ideal solution. है ना? Now you will just write ideal and non-ideal solution. Okay, ideal and non-ideal solution. So what is ideal solution? Just write first. ideal solution. So an ideal solution, please write with me, an ideal solution is the solution which obeys Rod's law over the entire range of concentration, over the entire range of concentration, entire range of concentration. So what it is saying that PA will be equal to P naught A chi A, and PB will be equal to P naught of B into chi B, and evidently we can also write P total will be equal to P naught A chi A plus P naught B chi B. This is the meaning that it will obey the entire rod. It will obey the Rod's law over entire range of temperature. It is the meaning that whatever you are experimentally, whatever you are getting the value as experimental should be equal to the calculated value. Okay. So here also we can write the most important point for ideal solution will be that the attractions between the molecules of individual component will be same as the attraction after mixing, will be same as the attraction after mixing. Okay. Now, next is what are the different characteristics? So please write. Characteristics of ideal solution. The first characteristic will be regarding the volume change. Okay, so we'll write volume change on mixing. Volume change on mixing should be 0. Okay, volume change should be 0. That means if V1 and V2 are the volume of individual components, then the volume of solution will be V1 plus V2. ठीक है, अगर ये पॉइंट आपको समझ में नहीं आ रहा अभी, then just bear with me. When you will understand the characteristic of non-ideal solution, उस टाइम आपको ये वाला पॉइंट समझ में आ जाएगा. ठीक है, ideal solution का. So volume change on mixing, it should be equal to 0. It should be equal to 0. So हम लोग कैसे define करते हैं? We can define this as the delta V volume of mixing should be equal to 0. Okay. Now, moving further on, second point will be heat change on mixing. Heat change on mixing. Heat change on mixing should be 0. ठीक है, यहां तक लिखिएगा तो बताइए. Just yes sir, tell me yes sir, no sir, no sir, and then I will explain this thing. लिख लिया क्या आप लोगों ने?
Yes.
What about others? Hanifa and Dania?
Yes, sir.
ठीक है?
Yes, sir.
Okay. Now, don't write further on. यहाँ पे आप देखिए AA है, BB है, and it is forming AB and AB. That means both of these bonds should be, or both of these attractions should be broken. And intermolecular force of attraction will be there. It will be broken, and these two will be formed. Correct? Yes or no? Tell me.
Yes.
Mu will be formed. Now, if the attractions are equal, that means the intermolecular forces of attraction between, that means before and after, if they are equal, that means whatever energy I am putting in to break, the same energy will be released when these two different bonds are formed. Got it? Yes or no? The energy
Yes.
required to break the bond, the magnitude of energy required to break the bond will be equal to the magnitude of energy that is released after the formation of the bonds AB. Is that clear? Yes or no?
Yes.
Anna, that is why what I can say, the delta H of mixing will be equal to 0. Is that understood? Yes or no? Please tell me.
Yes.
So you write when there is no change in the magnitude of when there is no change in the magnitude of attraction on the mixing of two components, the delta H mix will be 0. So in summary, what we can write about an ideal solution? So ideal solution should have the following characteristics. The number one point that you should never forget is ideal solutions should follow Rod's law. Okay, over entire range of concentration. Second point should be attraction before should be equal to attraction after. And due to this, the delta V mixing will be equal to 0, and the delta H mix will also be equal to 0. Okay. Also write some examples. Benzene and toluene. N-hexane. N-hexane means normal hexane and normal heptane. You can also write chloroethane and bromoethane. Okay, so all of these are examples for ideal solution. So you can easily see that there is no change in the structure or the molecular components of the system. Benzene with 6 carbon, toluene 7 carbon. So not much change, and that is why the intermolecular force of attraction is similar in both the cases. For benzene and toluene, it is equal, and between benzene and toluene, it will also be equal because they are having similar kind of structure, and the difference between the structure, the difference between the structure is not very high. कि आपको कुछ अलग हो जाए attraction, है ना? Your attraction will not be different; it will be same only. Done guys, आगे बढ़े.
Yes.
Okay. Now I'll write about non-ideal solution. ठीक है. Okay. So what will be the non-ideal solution? The solution which do not obey Rod's law over the entire range of concentration. The solutions which don't obey Rod's law over entire range of concentration. And what does that mean? It means that PA will not be equal to P naught A chi A, and similarly the pressure due to B will not be equal to the P naught B chi B, and as a consequence the P total of a solution will not be equal to P naught A chi A plus P naught B chi B. Also, the important point is the intermolecular force of attraction before mixing and after mixing will be different. Done? Yes or no?
Yes.
Okay. The 2 points you can write is characteristic में आप लिख सकते हैं दोनों point. Change in volume will be non-zero लिख सकते हैं ना, non-zero. ठीक है, इसको एक्सप्लेन कर देते हैं how it will be non-zero. Wait, okay, we will explain how it will be non-zero. ये पहला केस लेते हैं जब आपका attraction before is greater than attraction after. Is that okay? This first case, attraction before is less than attraction after. Oh, sorry, before is more than attraction after. Yes or no?
Okay.
ठीक है. So attraction is lower. If attraction is lower, molecules are far apart. Correct? Yes or no?
Yes.
Which means volume will be higher or lower. If molecules are far apart, the volume will be
High. So
higher.
higher.
है ना? So volume is higher. If we take this case in which the attraction after is more, if the attraction is more, then we can say that molecules are nearer than before, and that will lead to volume which is lower. Yes or no?
Yes.
Is that clear? है ना? Now, if the attraction is equal, that means before and after the volume will be same. That is why the mixing will, before mixing and after mixing, अगर हम volume को check करेंगे, तो it will be not, they will be not different, they will be same only. That is why delta V mix is 0 in the case of ideal solution. And in non-ideal solution, what will happen? Change in volume will be non-zero. Secondly, you can write change in enthalpy of mixing. इसमें ऐसे लिख सकते हैं लोग, delta V of mixing is not equal to 0. Enthalpy of mixing will be non-zero. मतलब delta H mix will not be equal to 0. अब यहीं पे we can summarize the case of non-ideal. काम करते हैं, इसी को लेके चेंज कर देते हैं बस. So non-ideal solution should not follow Rod's law. Attraction before is not equal to attraction after. Volume is not 0. Delta S mix is also not 0. Copy this down. Let me know when you're done. Then we will look at types of non-ideal solution. इसमें हम ये देखेंगे कि जब प्रेशर टोटल ज्यादा होता है, जब प्रेशर टोटल कम होता है. ठीक है, प्लीज राइट दिस डाउन. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Okay. Right, next, types of non-ideal solution. Types of non-ideal solution. There can be two types of non-ideal solution. The first case will be when the P total that you are measuring, it is greater than the experimental one, that is P naught A chi A plus P naught B chi B. Okay. The other case, it will be P total, it is less than P naught A chi A plus P naught B chi B. Okay. अब देखें, when the P total, it is what? It is greater than the experimental. यहाँ पे क्या आपका P experimental जो है, that is greater than calculated. That is why it is known as the positive deviation. ये क्या बोलते हैं इसको? Positive deviation from Rod's law. And when P total is less than the, that means the calculated one, so क्या बोलते हैं? Negative deviation. From Rod's law. Is that clear? Yes or no? Please tell me.
Yes.
ठीक है, अब देखिए positive deviation from Rod's law, इसका consequence क्या होगा? If it is positive deviation from Rod's law, that means we have more vapors than expected than the calculated one. We have more vapors, yes or no? That is why we are having more vapor pressures.
Yes.
Yes or no? Please tell me. हनीफा, दानिया, क्या हो गया? आप लोग कुछ नहीं बोलते हैं, समझ में कैसे आएगा? आप लोगों को समझ में आ रहा है नहीं आ रहा? Is Dania and Hanifa, tell me.
Yes, sir.
If P total is higher, that means there will be more vapor or less vapor?
More.
There will be more vapor. If there is more vapor, that means the molecules are escaping easily or not escaping easily. If there is more vapor,
They are escaping easily.
They are escaping easily. If they are escaping easily, that means the attraction is lower or higher?
It is lower.
Lower, है ना? तो यहाँ पे क्या होगा?
Yes, sir.
The consequence will be, Z आपको आया yes or no?
Yes.
ठीक है. So intermolecular forces of attraction is lower after mixing. उसकी अपोजिट यहाँ पे क्या हो जाएगा कॉन्सिक्वेंस में? IMF of attraction is higher after mixing. ठीक है. अच्छा, अगर अट्रैक्शन लोअर है इसमें हम लोग बोल सकते हैं ना वॉल्यूम दैट इज अच्छा ये बोल सकते हैं हम लोग वॉल्यूम फाइनल जो होगा इफ अट्रैक्शन इज लोअर इट विल बी ग्रेटर देन द वॉल्यूम इनिशियल. सही है ये सर? नो,
Yes.
दैट मींस डेल्टा V इट विल बी इक्वल टू पॉजिटिव. करेक्ट है बिकॉज फाइनल माइनस इनिशियल होता है ना. डेल्टा V will be delta final minus V initial and V final is greater than V initial, that is why this will be equal to positive. यहाँ पे अगर हम बात करें
So can we write delta V is greater than 0?
हाँ लिख सकते हैं नो प्रॉब्लम.
Because in exam I write like that.
हाँ लिख सकते हैं नो प्रॉब्लम.
Yeah.
सेम थिंग है सेम थिंग.
Okay.
V final will be less than V initial and that is why delta V it will be negative. ठीक है, delta V will be negative. So please write these points. तो आपके पास दो डेविएशन है दो टाइप डेविएशन है. पॉजिटिव डेविएशन फ्रॉम रॉड्स लॉ, देयर इज नेगेटिव डेविएशन फ्रॉम रॉड्स लॉ, है ना. पॉजिटिव डेविएशन में प्रेशर ज्यादा है, एक्सपेरिमेंटल ज्यादा है ना, पी टोटल ज्यादा है, और नेगेटिव में क्या है, पी टोटल कम है. इज दैट क्लियर? यस और नो प्लीज टेल मी.
Yes, sir. Yeah.
व्हाट अबाउट अदर्स? Okay, so now we will explain the positive deviation, then we will explain the negative deviation. Okay, लिख लिया सबने? Yes or no please tell me.
Yes, sir.
Okay. Explanation of, एक सेकंड रुक जाइए, पता नहीं क्यों इतना गंदा हैंडराइटिंग लिख पा रहा मेरे से. So we are considering the example of ethyl alcohol or ethanol plus cyclohexane. ठीक है, so ethanol is C2H5OH. Cyclohexane is how much? Cyclohexane will be, बताइए क्या होगा फॉर्मूला cyclohexane का? C6H कितना होगा? अरे क्या हो गया? Cyclohexane will be, oh my god, cyclohexane will be C6
H6.
H6 तो बेंजीन का होता है भाई. C6H12
Actually.
दो हाइड्रोजन इधर, दो हाइड्रोजन इधर, दो हाइड्रोजन इधर, है ना. Getting the valency as 6, sorry, getting the valency as 4 for each carbon, C6H12. अच्छा, यहाँ पे आई होप ऑल ऑफ यू कैन सी द IMF विल बी, IMF किसके लिए क्या होगा, इथाइल अल्कोहल के लिए, IMF विल बी इक्वल टू हाइड्रोजन बॉन्डिंग, यस और नो, because you have OH group here, there will be hydrogen bonding. And यहाँ पे क्या होगा, there will be only dispersion forces और van der Waals forces, है ना, तो लंदन फोर्सेस लिख देते हैं यहाँ पे, लंदन फोर्सेस. So now here we have hydrogen bonding and here we have London forces. अब इन दोनों को मिक्स करना है. So obviously you can see, as of now you can easily see ना that the intermolecular force of attraction of hydrogen bonding is greater than London forces. Yes or no, please tell me.
Yes,
पता चल रहा है आप लोग को, ठीक है. अभी तक तो हम लोग क्या कर रहे हैं सर, we are just taking the components of the solution A and B individually भी हम देख रहे हैं, ठीक है, individually देख रहे हैं. Now after mixing, ठीक है, अब आइडियल केस लेके चलिए आप हाइड्रोजन बॉन्डिंग का, यू आर टेकिंग द केस ऑफ हाइड्रोजन बॉन्डिंग. इफ यू आर हैविंग हाइड्रोजन बॉन्डिंग, उसमें क्या होगा, हाइड्रोजन बॉन्डिंग इज देयर एंड देन यू आर एडिंग cyclohexane. So when you add more and more cyclohexane will hinder in the formation of hydrogen bonding. That means C6H12 कहीं पे भी आएगा तो आसपास की जो इथेनॉल मॉलिक्यूल है, they will not be able to interact with ethanol molecules जैसा कि पहले कर पा रहे थे. When you have only ethanol, then you are interacting with only ethanol. Now, the ethanol molecules, they are bound to interact with cyclohexane molecules which are having London forces and they don't form hydrogen bonding. So previously each and every molecule of ethyl alcohol, they were forming hydrogen bonding, but as soon as we start to add cyclohexane, what will happen, the formation of hydrogen bonding will be decreased. Is that clear, yes or no? समझ में आया सबको, हनीफा, दानिया,
Yes,
yes
sir.
or no?
Yes, sir.
Yes, sir.
Okay, after mixing, the extent of hydrogen bonding of ETOH, ethyl alcohol, will decrease, है ना, it will decrease and hence the P total will increase, है ना, because intermolecular force of attraction घट गया तो P total क्या हो जाएगा, increase and will be more than calculated, और P नोट एक लिख देते हैं, more than P नोट A का A plus P नोट B का B. Please write this down, let me know when you're done. Done? Let me know if you're done.
yes, sir.
Okay. So next thing that we can write here is, अच्छा V mix के बारे में तो हमने पहले ही लिख दिया था, है ना, वॉल्यूम मिक्सिंग के बारे में फिर भी लिख लीजिए यहाँ पे. यहाँ पे क्या होगा, वॉल्यूम मिक्स क्या हो जाएगा, डेल्टा V ऑफ मिक्सिंग, इट विल बी ग्रेटर देन 0 का रहता ना, पॉजिटिव होगा तो ग्रेटर देन 0 बिकॉज इंटरमोलेक्युलर फोर्स ऑफ अट्रैक्शन इज लोअर. अच्छा, उसके बाद डेल्टा H मिक्सिंग की अगर हम बात करें तो क्या होगा, AA प्लस BB giving me AB plus AB. So these attractions, these are greater than the formation, है ना. अट्रैक्शन कहाँ पे ज्यादा है, यहाँ पे ज्यादा है आपके पास, इनिशियली अट्रैक्शन ज्यादा है, फॉर्मेशन के बाद अट्रैक्शन कम है. दैट मीन्स if there is more attraction, I have to give more energy to break this bond and there will be less energy released when I am forming the bond. And that is why the delta H mixing की अगर हम बात करें तो इसमें क्या है आपका, जो H of क्या है initial is greater than the H of final. Yes or no, please tell me. Initial is greater, yes or no? What happened, guys? Am I audible? Zaid, Hanifa, Dania?
Yes,
Yes,
sir.
है ना? So what we are having, we have to give energy, na? We have to give energy, and we are getting, like after mixing, we are getting less energy. So H fraction is greater, that means you have to give more energy to break. And if you have to give more energy to break, that means delta H of mixing will be equal to positive. Or rather, I should write delta H mix should be also greater than 0. That means the dissolution process, dissolution is endothermic. Endothermic means that means it requires energy. Okay, so please write this down. यहाँ तक let me know when you're done.
So done.
Done ना? ठीक है.
Done, sir.
अब देख. Okay, so I am borrowing a graph of Rod's law. जो आपका ग्राफ था रॉड्स लॉ का, उसको हम बोरो कर रहे हैं यहाँ से. Get down. Oops, 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 oops. क्या हो गया? Sorry. तो यहाँ पे एक और पॉइंट लिख लीजिए, जो कि आपको लिखना चाहिए था, पहले ही लिख लेना चाहिए था इसको, कि जो पी ए विल बी ग्रेटर देन पी नॉट ए का ये, है ना, एंड पी बी विल बी ग्रेटर देन पी नॉट बी का बी, एंड कॉन्सिक्वेंसली द पी टोटल will be greater than P naught A chi A plus P naught B. Chi B. ठीक है? And then we'll make the graph. So all these lines that you are seeing here, ना, these are for ideal condition. अब यहाँ से ना हम इनको हटा दे रहे हैं जो labeling है यहाँ पे. Why? Because you already know these things, है ना? You know these things. अच्छा, यहाँ पे क्या होगा? When you have, see, PA is greater than P naught A chi A and PB is greater than P naught B chi B, है ना? So and P total is greater than P naught A chi A plus P naught B chi B. It means that जो भी pressure आप measure करें, that will be a bit higher. That will be a bit higher. That means we can say that this can be the curve for pressure, है ना? Obviously, when you are having only A, है ना? That means in this case, when you are having only A, the pressure will be equal to what? The pressure will be equal to P naught A only, है ना? The pressure will be equal to P naught A only, and in this case, it will be equal to P naught B. लेकिन बीच में क्या होगा? It will increase, right? Because P total is greater than P naught A chi A plus P naught B chi B. Similarly, for the red graph, I can say that. अच्छा, इसको क्या करते हैं? इसको ना, this one I should dash it. ठीक है? I will dash it, and इसको भी dash कर देते हैं. ठीक है? And then we can draw a curve like this. कर्व समझ में आ रहा है आप लोगों को, है कि नहीं, ये बताइए पहले.
Yes, sir.
Yes, sir.
है ना, कि ऊपर से क्यों जा रहा है? क्योंकि प्रेशर ज्यादा हो चुका है. So it will be higher. So आपको ऐसे जाएगा. ठीक है? So this will be the graph for positive deviation from the also. ठीक है? Please write this down. Let me know when you're done. ग्राफ बनाइए.
Sir, finished.
What about others? Okay, Hanifa is also done. ठीक है. Next, let us explain the negative deviation. ठीक है? Explanation of negative deviation. explanation of negative deviation from Rod's law. So for this, we will take the example of this is a very good example है ना. इसमें क्या लेते हैं? Acetone and chloroform. Okay, so we are taking what? Acetone and chloroform. So acetone का structure क्या होता है? What is the structure of acetone? Can somebody tell me? No idea. ठीक है, देखिए. We have carbon, a double bond, CH3 and CH3. ठीक है? CH3 and CH3. Okay, what is chloroform? Chloroform is carbon.
Carbon with four-sided chlorine.
नहीं, तीन chlorine.
तीन chlorine, एक hydrogen.
Okay, तीन chlorine और एक hydrogen. ठीक है? This is your chloroform. This is your chloroform. I will just wait a second. इसको हम ना थोड़े दूसरे तरीके से बनाते हैं, so that we can explain some things. ठीक है? Now, if I look at acetone here, then I can see there is delta negative here, there is delta positive here, and that means this is a polar molecule. ठीक है? This is a polar molecule. If I look at the CCl3, CHCl3, then here we have delta negative, delta negative, delta negative, and here also we can see that there is some kind of polarity here also. You say that this molecule is also polar, है ना? This molecule is also polar. Both of these are polar molecules. And this is all this thing is before mixing. Then we are looking at each of them individually. But as soon as we mix them, see, यहाँ पे क्या आपका delta negative, यहाँ पे भी delta negative, यहाँ पे भी delta negative. तो ये carbon में क्या आ जाएगा? Delta positive. Okay, please listen very carefully. Leave your pen aside. Please listen very carefully. If you have delta positive here, and there is a hydrogen here, यहाँ पे क्या आपके पास hydrogen है? If you have delta positive, then the electrons will be pulled by carbon. Yes or no? Please tell me. Electrons will be pulled by carbon. Now, leaving a very high delta positive charge on this hydrogen, because we have 3 chlorines, and after 3 chlorines we have 1 carbon. So all the 3 chlorines are also what? They are also withdrawing the electrons, है ना? They are withdrawing the electrons from carbon directly and indirectly from hydrogen. So हर तरफ से क्या करते हैं chlorine? They are pulling up electrons. Okay, they are pulling up electrons, and here we have hydrogen, which is delta positive. Now, when we mix them, when we mix acetone, that is having an oxygen atom here. So you all should know that oxygen atom, it contains lone pair electrons, and it is also delta negative. So what will happen? Both of these will interact. So you have oxygen and hydrogen which are interacting, and that leads to the formation of hydrogen bonding after mixing. That means what is happening? Attraction increases. Correct? Yes or no? Please tell me, all of you.
Yes.
And so this is how the attraction will increase. है ना? When you have, like for example, in this case, acetone and chloroform, उसमें क्या? दोनों starting में polar है. And then after mixing, there is hydrogen bonds forming. If the hydrogen, and we all know that hydrogen bond is more attractive and it has more magnitude than the only polar ones. Is that right? Yes or no? Please tell me. What about others? समझ में आया सबको?
Yes,
Yes,
sir.
sir.
Okay. And here also write a few things जिनको हम बहुत ज्यादा, आपको explanation तो समझ में आ गया है ना? If you want to write, एग्जाम में कभी लिखने के लिए आया तो यहाँ से आपको पढ़िएगा, सेम चीज को छापना रहेगा, है ना? ऐसा तो नहीं सिर्फ नेगेटिव डिवीजन पूछेगा, पॉजिटिव नेगेटिव दोनों का डिफरेंस पूछेगा, तो पॉजिटिव में जो है उसका उल्टा लिख दीजिएगा बस नेगेटिव. यानी कि यहाँ पे जो डेल्टा वी मिक्सिंग है, पहली बात तो ये, इसमें हम लोग ऐसे लिखेंगे कि जो आपका PA है दैट विल बी लेस देन P0 A का ये, एंड जो PB है दैट विल बी आल्सो लेस देन P0 B का B. उसकी वजह से P total will be also less than P0 A का A plus P0 B का B. and if the pressure is lower, है ना, pressure lower की बात तो छोड़ दीजिए, अब आ जाते हैं attraction के ऊपर. If attraction is increasing, that means if attraction is increasing, that means the V final will be less than V initial, है ना. After dissolving, attraction is increasing, molecules are close together. When molecules are close together, what is going to happen? They will be taking less and less volume, and that is why the delta V, which is equal to V final minus V initial, this will be equal to final is lower. That means this will be equal to minus. That means negative. So delta V क्या हो जाएगा आपका? It will be less than 0. Similarly, जो आपके पास delta H होगा, attraction is increasing. If attraction is increasing, that means there will be more energy release. जब more energy release होगा तो क्या होगा? Negative. Delta H will be negative, and the process will be exothermic. Please write this down. समझ में आ गया ना सबको? Each and every part is clear.
Yes, sir.
Ideal,
Yes, sir.
non-ideal में? Okay. अच्छा, इसमें प्लॉट आपको बनाना पड़ेगा ना? ठीक है, तो इसमें जो प्लॉट होगा will be very similar to the one we made previously, लेकिन उसमें जो प्लॉट्स में जो लाइन से वो सिर्फ ऊपर जा रहे हैं, इसमें क्या होगा? they will be going downwards. Oops, ज्यादा ही हो गया. Okay. Now this is the ideal case है ना, the dotted line है वो ideal case है. अभी इसमें जब negative deviation है तो उसमें आपका जो pressure है that is lower. The pressure it is lower. Pressure is lower. Do you guys know about distillation? Distillation पढ़ा है आप लोगों ने?
Yes, sir.
Yes, sir.
Distillation पढ़ा आप लोगों ने? किसी को कुछ पता है? थोड़ा explain कर सकता है distillation कैसे काम करता है?
Sir, if the water is unpurified, we purify the water with the help of distillation, and the tools are used. Sometimes they use, I think I'm not getting the word. They use a tool that is in
Main
Hindi.
concept क्या है? Like I'm asking, like for example, in water I have, let us suppose, I have water and oil. ठीक है? So can we distill them? Distillation हो सकता है?
Yes.
Yes.
I
Okay.
didn't get
How
your
can
word.
water and oil?
Water and oil.
Water and oil.
With the help of flask.
Distillation. हाँ.
Yeah.
So why, like how it will get distilled? क्या चीज है ना, कुछ कोई तो ऐसा concept होगा ना. For example, if I'm saying water and oil, so what is the difference between water and oil जिसकी वजह से we are able to distill them?
On the basis of their density.
Density. आप बता रहे हो या फिर मतलब आपको लग रहा है ऐसा, या फिर आपको पता है?
लग रहा है.
अच्छा, लग रहा है. Anyone else? क्यों बता सकता है? और अच्छा ठीक है, आई विल हेल्प यू आउट. ओके, हनीफा एंड दानिया, बोथ ऑफ यू आर लाइक इन द सिमिलर प्लेस, कि नहीं समझ में आ रहा है कि डिस्टिलेशन कैसे काम करता है.
Yes, sir.
सिमिलर प्लेस. ओके. अच्छा, डिस्टिलेशन में बॉईल होना जरूरी है, सही है?
Yes, sir.
yes sir. If it is not getting boiled, that means distillation होगा या नहीं होगा? अगर कोई चीज हम गर्म कर रहे हैं लेकिन फिर भी बॉईल नहीं कर रहे हैं, सो डिस्टिलेशन होगा या नहीं होगा?
No, sir.
नहीं होगा. ठीक है. अच्छा, अब ये बताइए, व्हाट डू यू थिंक, आप एक टेम्परेचर बता दीजिए. पानी का तो बॉईल करने का टेम्परेचर 100 डिग्री सेल्सियस. तेल कितने डिग्री सेल्सियस में बॉईल करता होगा, बताइए. व्हाट डू यू थिंक? दोनों, बॉइलिंग इज समथिंग दैट इज कांस्टेंट विद ईच एंड एवरी डिस्टिलेशन प्रोसेस. नाउ आई एम सेइंग, अगर वाटर और ऑयल को बॉईल करना है, सही और गलत हमको भी नहीं पता कि तेल, अब ये डिपेंड करेगा तेल कौन सा है. हनीफा बताइए, गिव मी अ टेम्परेचर एट विच you want the oil to boil.
200.
How much?
200.
200 degrees Celsius. ठीक है, very good. 200 degrees Celsius. All of you heard this, yes or no? पानी कितने में हो रहा है? पानी
100.
100 and the oil is boiling at
200.
200 degrees Celsius. ठीक है. Now, अब हमने चालू किया, क्या क्या हमने चालू किया बर्नर, अब हम हीट करने लगे. ठीक है, तो पहले 100 डिग्री सेल्सियस पहुंचेगा या 200 डिग्री सेल्सियस पहुंचेगा?
100.
100 डिग्री सेल्सियस पहुंचेगा. अच्छा, 100 डिग्री सेल्सियस पहुंचेगा एंड देन व्हाट विल स्टार्ट, द वाटर विल स्टार्ट टू बॉईल,
Yes.
है ना?
Yes.
all of you know ना that when the water is boiling 100 डिग्री सेल्सियस से ऊपर टेम्परेचर जा ही नहीं सकता जबकि सारा का सारा पानी कन्वर्ट ना हो जाए वेपर में.
Yes. Yes.
व्हाट इज दिस? लेटेंट हीट, राइट? लेटेंट हीट याद है, क्लास 9 में कांसेप्ट इंट्रोड्यूस किया गया था, लेटेंट हीट
Yes,
का.
Yes.
You all remember it, right? Latent heat, right? Now, इसका मतलब जब तक पूरा का पूरा पानी है ना, जब तक, अब हम देखिए, this is how distillation is done. You have water and oil, उसमें आपने क्या किया, हीट करना चालू किया. Then there is thermometer there. ठीक है, आपने थर्मोमीटर को लगाया. थर्मोमीटर जो है पानी में टच कर रहा है ना, it is touching the water that is there in the round bottom flask, है ना, the flask that we take it is round bottom flask. उसमें पानी पे टच कर रहा है वो, है ना, पानी या तेल जो भी सोल्यूशन है उस पर टच कर रहा है. And then what happens when then slowly the temperature increases 80 degree, 90 degree, 95 degree, 97 degree, 90 degree, 100 degree में आके वो रुक जाएगा. Okay, at 100 degree it will stop. 100 degree में रुक गया. I mean, let us say it takes 2 minutes, 3 minutes, 4 minutes. 3-4 मिनट में क्या हुआ, पानी सारा का सारा बॉईल हो गया. अब जैसे ही 100 डिग्री से ऊपर जाने लगा ना, इफ यू सी दैट इट हैज वेंट फ्रॉम 100 डिग्री सेल्सियस टू 110 डिग्री सेल्सियस, इसका ये मतलब है कि सारा का सारा पानी क्या हो गया, बॉईल हो चुका है. अब फिर से क्या हो रहा है, जब हम हीट कर रहे हैं तो टेम्परेचर इंक्रीज हो रहा है, ना कि फेज ट्रांजिशन हो रहा है ना. तो नथिंग इज गेटिंग कन्वर्टेड फ्रॉम लिक्विड टू गैस इफ द टेम्परेचर स्टार्ट टू इंक्रीज फ्रॉम 100 से 110. इज दैट क्लियर, यस और नो? सही
yes,
है ना? अब बस वही है कि आप क्या कीजिए, अब सारा का सारा क्या हो चुका है, वाटर हैज इवेपोरेटेड तो नहीं, बॉइल्ड यानी टर्न इनटू वेपर, ऊपर गया. देन फ्रॉम द पाइप इट विल बी कवर्ड इनटू सम कोल्ड वाटर फ्लास्क, है ना, उससे आप ठंडा हो जाएगा तो फिर पानी में कन्वर्ट हो जाएगा जो वेपर है, एंड देन इट विल गेट डिस्टिल्ड आउट. नाउ व्हाट वाज द डिफरेंस? The difference between the two components, between the two liquid, was the difference in their boiling points, है ना? Yes or no?
yes, sir.
Right? They are boiling points. So distillation का जो main concept है, अगर दो liquid का boiling point same हो गया, if you have a liquid, if you have two liquids, है ना, if you have two liquids, जिसमें मान लीजिए एक का आपका टेम्परेचर है बॉईल करने का 100 डिग्री सेल्सियस, दूसरे का है बॉईल करने का टेम्परेचर 105 डिग्री सेल्सियस, क्या इन दोनों को डिस्टिल किया जा सकता है? एक का 100 है और एक का 105 है. Now since the difference between those two temperature is not very high, it is not possible to separate them through distillation. Is that right? है ना? अरे
Yes.
हाँ या ना?
Yes,
है
sir.
ना? ठीक है. Similarly अब एक कंसेप्ट आता है. फॉर एग्जाम्पल जो केस हमने अभी लिया था इसका, हाँ, अब ये बताइए, एसीटोन है पोलर, ठीक है, क्लोरोफॉर्म भी है पोलर, ठीक है, लेकिन जब ये दोनों मिक्स कर जा रहे हैं तो क्या बना ले रहे हैं, हाइड्रोजन बॉन्डिंग, ठीक है. सो इट विल हैव सर्टेन टेम्परेचर बिफोर मिक्सिंग, इसका आफ्टर मिक्सिंग क्या हो जाएगा, देयर विल बी अ न्यू टेम्परेचर बॉइलिंग पॉइंट जो है सोल्यूशन का क्या हो जाएगा, द सोल्यूशन they will be having intermolecular forces, new intermolecular forces such that they will have a completely new boiling point, और उनका boiling point ना तो आपका एसीटोन से मैच करेगा, ना तो आपका क्लोरोफॉर्म से मैच करेगा. Okay, so now there are some solution in which what happens, there are some solution in which the boiling point that you are going to get here, it is going to be a new boiling point, जिसमें आपका ना ही वो क्लोरोफॉर्म से मिलता है, ना ही वो एसीटोन से मिलता है. Okay, so do you understand why is this happening? Because initially क्या था, boiling point किस पे डिपेंड करेगा, polarity पे. So you have polar bonds here, so it will have certain kind of certain boiling points. Chloroform भी क्या है आपका, polar है, it will have certain boiling point. लेकिन when you are mixing them, they're completely forming a new molecular force, they're completely forming a new intermolecular force of attraction that will determine the boiling point. हाइड्रोजन बॉन्ड हो गया तो अब क्या हो जाएगा, बॉइलिंग पॉइंट और हाई हो जाएगा. और सिर्फ एसीटोन या सिर्फ क्लोरोफॉर्म के लिए नहीं होगा हाई, इट विल बी हाई फॉर बोथ ऑफ देम. यू गॉट माय पॉइंट? मिक्स करने के बाद क्या हो गया, द बॉइलिंग पॉइंट बिकेम 1, सेम हो गया. ऑल ऑफ यू गॉट दिस पॉइंट, यस और नो, प्लीज टेल मी.
Yes, I got it.
Yes.
Yes.
Hanifa, Dania,
Yes,
ठीक है. So these type of solution which have the type of solution which have, or which we can say that they boil at a constant temperature, है ना. The solution का मतलब क्या होगा, there will be 2 or more than 2 components and they are boiling at what, at constant temperature, and we cannot distill them in the compositions. These are known as azeotropes, ठीक है, और या फिर azeotropic mixtures. क्या बोलते हैं हमको, azeotropes. ठीक है, so we'll be learning about azeotropes. ठीक है, we'll be learning about azeotropes. अब देखिए इसमें आपको ना थोड़ा सा हम हिंट दे देते हैं, एजियोट्रॉप्स के बारे में थोड़ा सा हिंट दे देते हैं. एजियोट्रॉप का रिलेशन जो है रॉल्स लॉ से ही है. एजियोट्रॉप का रिलेशन किससे है, रॉल्स लॉ से. जैसे कि आपने अभी देखा, इफ वी आर हैविंग व्हाट, इफ वी आर हैविंग सी नेगेटिव डेविएशन, ठीक है, इफ यू आर हैविंग नेगेटिव डेविएशन, देन व्हाट इज हैपनिंग, आईएमएफ इज इंक्रीजिंग, सही है. एंड इफ यू आर हैविंग पॉजिटिव डेविएशन, आईएमएफ इज लोअरिंग. ठीक है, आईएमएफ क्या हो रहा है, पूरे सोल्यूशन का ही लोअर हो जा रहा है, किसी एक कंपोनेंट का नहीं लोअर हो रहा, the whole solution is getting lowered. Now if there is a particular solution which is showing a very high negative deviation, उसमें intermolecular forces बहुत ही ज्यादा high हो जाएंगे, intermolecular forces will be very high and these will require a higher boiling point, and that is why these are the azeotropes which will be formed and which will show negative deviation. They will be known as maximum boiling azeotrope. और जो ऐसे कुछ azeotropic mixtures होंगे that will show a high deviation in a very high positive deviation from Rawls law, उनमें क्या होगा, intermolecular force of attraction it will be getting very very lower. और जब intermolecular force of attraction lower हो जाएगा, then we will be naming this as minimum boiling azeotrope. दोनों में फर्क समझ में आया, yes or no, tell me.
Yes.
What about Hanifa and Dania?
Yes, sir.
Yes, sir.
ठीक है,